Today we're going to go ahead and get into a kind of different variation of our sequences. We're going to talk about geometric sequence. So I guarantee that you probably have heard about this. And just like arithmetic sequence, today's class is going to be centered around another formula. The main big difference between geometric and arithmetic sequence is that arithmetic sequence you're going to add by the same amount every time, which we call common factor. So we add by that amount, and however, in the geometric sequence, we don't do that. We multiply by a common ratio. So for example, if I have, let's say, a number, let's say I have the number 2, I'm going to keep on multiplying by 2. And then after that is going to be 4, and then I multiply by 2 again. And then we essentially can write that as 2 times 2 to the power of n. So that is essentially a very simple geometric sequence. Alright, so the formula today is going to be t equals a, I should probably introduce this a little later, but yeah, it's t equals r to the n minus 1, essentially. Okay, so this is what's going on. So I have to kind of explain what are these things. So well, A is the starting term, just like arithmetic sequences. It's the starting term. R is the common ratio, and N is whatever term it is. So let's go ahead and try example 1. Given the formula of that, find the first 5 terms. So essentially, whenever we look at a sequence, we have to assume that well, the n that we have is greater than, well, not equal to 0. Sorry, r is not equal to 0 for this. So let's go ahead and write the first 5 terms. So let's start at we can start at n equals negative 1, or n equals 1, sure. So if we have n equals 1, we will have 5 to the negative 2 of 1 minus 1, which is 0, and so that's just 1, so that's going to be 5. That's our first term. And our second term is going to be 5 to the negative 2. 2 minus 1, which is 1. So 5 times negative 2, negative 10. And then essentially we're going to alternate again. So the final answer that you should have is 5, negative 10, positive 20, and negative 40. So we look at something and we're like, hey, great. The formula perfectly works for this. Because look, our common ratio is always negative 2. Right? We multiply 5 by negative 2 to get negative 10. Then multiply by negative 2 to get 20, and then negative 40, and then essentially 80, and we can go on and on and on. So this is what we all call an alternating series, an alternating sequence. Because first, look, the negative sign is going to be positive, negative, positive, negative, positive, negative. And this occurs when the common ratio is less than 0. So for example, any negative number is going to give you this alternating sequence. And let's go ahead and do example 2, which is determining, given the formula of the nth term, we're going to find the 6th. We're going to find what the 6th term is. So that's pretty easy, because T6 is equal to 3 to 6 minus 1. And that's just calculator work, because 6 minus 1 is 2 to the power of 5, which is 32 times 3, that's 96. So essentially, this is very simple and straightforward. As long as you understand the formula, you should have no problems with any of these problems. And then B is pretty much the same thing. F at 6, these are just functions. Negative 5, 4 to the 6 minus 1. So it's going to go ahead and give you negative 5 and 6 minus 1, 4 to the 5, 4 to the 5th power, and 4 to the 5th power, that is 1024. And And essentially 1024 multiplied by -5 is going to give you -5, 1, 2, 0. That's our answer. We're going to go ahead and look at example 3. So example 3 gives us find the formula of the nth term Tn and find T6 of this sequence. So earlier we learned our formula that we can use to do this. So Tn is equal to ARn minus 1. So we definitely have the first term, that's just 2. And our common ratio, we can see what multiplied by 2 is equal to 6. So that's 3. So 3 times 2 equals 6, and 6 times 3 equals 18. That makes sense. So our common ratio is 3. And our nth term is just n minus 1, right? Because we can't plug in any n. So this essentially is going to be our formula to find any term in this entire sequence. Tn equals to 2, 3 to the n minus 1. So let's go ahead and plug in 6 into this to find, well, the sixth term, obviously. So T6 is equal to 2, 3 to the 5. Now, 3 to the 5th power is it's a huge number. Let me just think. 243, I believe. Yeah, 243. So 243, and then we're going to go ahead and multiply by that by 2, so that's just 486. So essentially now we're going to answer the question. You write a conclusion statement. The formula to find the nth term is this, and the sixth term is 486, and T6 equal 486, blah blah blah. You write something like that. And let's go ahead and do example. Wow, where's my mouse? What? Whoa, okay. Let's go ahead and do example 4. So example 4, find the numbers of terms in the geometric sequence. So this is actually a very interesting one. However, we're still going to plug in the formula. So Tn is equal to ARn minus 1. So we know A, that's 3. Ratio, we definitely know, that's 2. However, we don't know how n. But we do know Tn. So this is our nth term, right? Because we don't know how many terms there are. We don't know how many terms there are. So we can only see that 384 is our nth term. So essentially, when we figure out n, we're going to be able to figure out how many terms there are. Right? So Tn, the nth term is 384, and then we have n minus 1. So now you get this very awesome equation that kind of lets you isolate for this exponent. So what do we do to isolate? We first divide by 3. So 384 divided by 3, that's 128. 128 equals to 2 to the n minus 1. Now that goes back to solving exponential functions. So 2 ways you can do this. Do a log method, or you can straight up just you can go ahead and write this as a power of 2. So you should know 2 to the 7 equals to 2n minus 1, which is n equals to 8. So there's 8th term. Or you can go ahead and separate this exponent. Because remember, if you have an exponent plus something that's multiplied by together, if you don't, it's divided by together. So 2n over 2 equals 128. So multiplied by 2, it's going to be 128 multiplied by 2, 256 equals 2n. And then you isolate, so log 256 over log 2, which is going to give you log 256 over log 2, log 256, and log 2. And you divide that, and it should give you 8 as well. So essentially n equals 8. There's 8th term. Yeah, you should get you should get the same answer no matter what methods you do. And then example 5 is it's a little smart trick that we do. So essentially we're gonna do some algebra, and you kind of do solving a system of equation kind of thing. So let's go ahead and do this. So we're gonna go ahead and write the formula again. So for every question that I do, I'm going to write the formula because that helps me, just strengthens my memory, and maybe I'll remember on the test. So Tn equals that. So we know T5. So T5 is equal to 1875. So we can go ahead and plug in everything that we know. So the fifth term, 1875, this is the T5. And then A we don't know, unfortunately. And R we don't know. But we do know the term though. That's 5 minus 1, that's 4. We're going to do the same thing for that. So 46875, 46,875. That's the seventh term. We still don't know AR, but we do know 7 minus 1 is 6. Right? So now, how do we solve this? How do we solve this? Well, we have to set them equal to each other. Or we have to kind of, find one into another. So we can do whatever we want. Let's just solve for A first. So let's go ahead and write this in terms of A. So this will go ahead and equal to A is equal to 1875 over R to the 4th power. Right? We just move it, but we just divide both sides by R to the 4th power. Right? Nothing bad, nothing stupid, nothing random, just mathematics. And then let's go ahead and plug that into this equation. So we'll have 46875 is equal to 1875 over R4 multiplied by R6, right? We just plug in for A. I mean, A is the same for both equations. I mean, it tells us this is the same sequence. So A should be the same no matter what, and so is R. So we multiplied this by R6. So R6 over R4, we know exponential law. So, right? So 6 and 4 cancels out. So that just become R squared at the top. And now let's divide both sides. So 46,875. We're going to go ahead and divide that by 1,875. That's going to give us 25. Equals to R squared. And then obviously we know what that is. R is just 5, right? And now we can plug it into any equation you want. So let's just plug it into the first one. So R equals 5. And 5 to the 4th power. So 5 to the 4th power, that is going to go ahead and give you 625. And it's 1875 divided by 625. That's going to go ahead and give you 3. So A equals. And now it tells us we have to first find the first 3 terms, and we found Tn. So we already have Tn. So let's go ahead and write it. So Tn is equal to A, which is 3, and R, which is 5, and minus 1. Alright? And we are done. Oh yeah, the first 3 terms. So the first term is 1 n equals 1, so 1 minus 1, that's just 0, 5 to the 1, so it equals 3, and we multiply by 2 to the 1, 5, which is 15. Then we do 75. Right, first 3 term. Now, you might think we're done, but funnily, we actually missed something really, really important. And I wanted to let you guys see how bad that would result in. So if this was a 4-mark question, we would have only gotten 2 out of 4. Because we're missing a whole set. So remember back when we did R squared equals 25? That we had to do plus minus. Because we didn't know if it's anything, and there was no limits to it. This is not a word problem, there was no limit, it's just mathematics. So essentially R could have equal to -5. And that would have been very different. So that will give us Tn equals to 3 -5 to the n minus 1. And our first 3 terms would then be 3 and -15 and 75. So yeah, whenever you're doing these type of questions, it's very straightforward. All of these questions are very easy, and I doubt if anybody in this class would have any funny problems or any struggles with it. The only part is careless mistakes, and you're always gonna make these careless mistakes if you don't read the question. And essentially, that is our last example. and that is your daily reminder not to make any mistakes and always to read the question and do all the mathematical procedures right. And as long as it doesn't have any requirements, you should always give it all the possible solutions to earn full marks. So here are some practice questions and homework questions that you should do. However, they're all centered around this one formula. So if you remember this formula and memorize it for the test, which I will not provide any formula sheet for. So as long as you remember these formulas, you should be fine on the test. And these homework questions are on page 452, 453, 454. And next lesson, instead of introducing, recursion formulas, which is basically we're gonna try to find out basically backtracking every term using the term after it. That's recursion formula. Instead of doing that, we're gonna go ahead and do some word problems as usual, because the word problems in